Hi, today we will discuss on time complexity and space complexity. To understand it in a better way, I am taking an example. Actually, this question is asked in Amazon interview. The question is pretty simple. Uh, just check whether given number is prime or not. Check whether given number is prime number or not. Yeah, obviously it looks simple, but we need to write an efficient code. Now we know that prime number is a number which have factors only one and itself. uh, Obviously factors means we know the number which divides with the reminder 0. Let's take example. For example, 1, obviously 1 is neither prime or composite. So if you take 2, yeah, 2 is divided by 1 and itself, so it's a prime. Yeah, 3, yeah, 3 is a prime because the factors are 1 and 3. 4, yeah, 4 is not a prime. It has the factors 1 into 4 we can write, 2 into 2 we can write. So again 4 into 1. So it has factors 1 to 4 more than 2. So it is not a prime. So similarly, 5 is a prime, 6 is not a prime. So now we will write a code. Now we will write a code to understand it. So let's take an any integer. For example, n is equal to suppose 12. So let's write its factors. Let's understand how we are going to write code for it. So we can write 12 in the ways 1 into 12, 2 into 6, and so 3 4 12, then 5 we can write the 6 into 2, then 12 into 1. So these 1, 2, 3, 6, 12 are the factors of 12. So obviously 12 is not a prime, but I'm writing a code. How can we write here? Okay, so first we will take loop from I equals to it's not 0, I equals to 1 to I is less than or equal to n, that is 12, and increment I plus plus. So if that I in divisible by I is equal to 0, that is if I divides n and remainder 0 means it's a factor. So then we will just here what we'll do means we will just take count equals to 0. After that here we will just increment count plus plus. Okay, so after uh, after this process, at the end we will just simply do, if obviously prime means the count should be 1 and itself, so 2. So then we will print prime, or else we will print it's not a prime. So actually here it is a brute force method. We are simply doing with a basic understanding. uh, if we write that code and run in our editor, then see, so I'm taking 12. 12 is yeah, 12 is not prime. So if you can see your code, I will take this else. Prime. So I will run again. So you can observe I'm taking for example ns12, and I'm from 1 to n, that is what we are doing here. We are checking whether it is divisible or not. If it is divisible, we are counting that factors, how many factors, like that. So finally, if it has counter as 2, it is prime, or else it is not prime. Okay, now the point is, uh do you think it is optimized code? Okay, now the question is, what is optimized code? So if you observe, it is in the statement, it is running from 1 to n. That is, if it is n is 12, okay, n is 14, 16, 13, anything is okay. What if is n is almost 10 power 8? So 10 power 8 times inside my for loop should run. So do you think it is optimized? Usually for a 10 power 8 iterations, it will take 1 second for model mission. So if it is more than 10 into 10 power 8, many, it will take 10 seconds, and so on. But what if, uh, can't we reduce time complexity here? Just observe, 1, 2, 3, 4, 6, and we know that any number greater than half of is this number. For example, 6, more than 6 we can't divide that number. So why can't we take up to only n by 2? And here count is equal to 1, because we are checking from 1 to 6 only. Yeah. So what happens here, I'm just taking from 1 to 2, and obviously the 1 will be divisible. So I'm checking here. Yeah, it's a not prime. For example, if I take 13 and I'm checking, yeah, it's a prime. So what's happening here, previously I'm running for 10 power 8 iterations, but now for only n, it reduced by half. That means 10 power 8 by 2 means we can decrease somewhat time, right? So less loops, less time. Okay, now uh actually this is how we should do the coding. We should focus on more observations. Like if you observe more and more, you you can get more optimized code. Yeah. uh we can try it once again. Let's observations more. Here what we should learn while solving the SA is, we should develop our observation skills, and we should form and some ideas. We should develop that ideas into code. Now the same, let's, okay, I'm taking 16. So let's write its factors. What are these factors? Oh, in how many ways we can write? 1 into 16, 2 into 8, 3 we can't write, 4, 4 4 is 16, and then 5, no, 6 we can't write, 7, 8 we can write, 8 to the 16, and 16 into 1. So these are the factors 1 to 16. So we already taken from half of it. So we are to n by 2 previous time. Now what I am going to do is, I am observing something, so I can reduce my code here. I'm just doing some observations. What are the observations happening? For example, it's 1, 2, 4, 8, 16. For example, if you observe, after 4 the factors are repeating. For example, 116 we have checked, 2 8 we have checked. If 2 is a factor, 8 is also a factor, right? If 4 is a factor, yeah, obviously, actually we will write a special condition. And if 8 is a factor, 2 is a, so this 8, so 2 here already we have checked. If 16 is a factor, means 1 is also a factor, we already checked. So what we are going to do, if you observe, like if you take another number 12, how can you write 1 into 12, 2 into 6, 4 3s are 12, and actually 3 into 4. So after 4 into 3, so it is repeating again. It 6 into 2, and again 12 into 1. That means how the relation is going to 12 to 3, 16 to 4. Yeah, if you observe, it is nothing but square root. If you take square root of 16, it is 4. If you if you take square root of 12, it will be around some around between 3 and 4, 3 point, but it is integer, right? Int we don't take float, so we will take 3. So now we will write, now we will write the code uh here itself. Yeah. So take, so first we will take input, for example 16. After that I'm going to take in the for loop from I equals to 1 to I is less than or equal to root of n and I plus plus. Now you have one special case, right? If it is perfect square means 4 4, although it is double, although it is double, for example how it is, for example if uh, n divided by I is equal to 0, that means what are the factors, even inside the factors, again if I is equal to n by I, that means if it is 4, 4 is equal to again that 16 by 4, if it is the repetitions, or else that if, so here we will count only one time, count plus plus, but else for other cases, for example it is 1 2, that time if one factor is there, other fact other will be also there is a factor, so we will increment count as 2, count plus 2. So obviously how we gonna do, so we will check, we are checking from I to root n. So if count is equal to 1, we can get prime, or else we don't get. So I will run this code and show to you. Yeah, this is a code. Yeah, actually there is an mad dot power. What is that? I will explain here. Yeah. Mad dot power is nothing but is root means 1 by 2, right? 0.5. So mad dot power n is for example I can take anything, I'm taking 16. So n power 0.5, that is a mad power, that is a function. So I'm running here. Yeah. So wait, I'm adding one. Okay, now the code is perfect. Right. Yeah. 16 is not a prime. So what we are going, what we have done here, from I'm checking from I equals to 1 1 to I can check, but I'm writing more efficient code like, yeah it is. So even I can write more efficient code like after if 2 is divisible means there itself we can print not a prime, right? So I can take this statement, I can break it, and if it is not at all, we can print as prime. You can check this code once again, it is more optimized way. So what I want to say is, at first I have done the iterations in n, after I have done in iterations in n by 2, after I have done in iterations as root of n. So in n, by reducing the iterations, I am reducing the time complexity. For example, for if the input is very huge, but the n is almost 10 power 8 means it max, it will get almost 1 second for model mission. For n by 2 will get less. If even if it root of n, that means 10 power 8 root means it is 10 power almost decreasing. So half of we get, so we are reducing the time complexity. So these observations really helps a lot. Like if there is if there is two algorithms, we need to check which is more optimized. Like for example, if one code is we are getting n square, other code we are getting root n, in other code we are getting n by 2, then this is a algorithm 1, this algorithm 2, this algorithm 3, then obviously which algorithm we should take for optimization? Yeah, the correct is root of n. So this analysis helps a lot. In the next video we will discuss big O notation, or we'll write order of n, which is very important for analyzing the time complexity of various data structures and algorithms.